questions, level 3 and 4, 2020.
A mushroom grows a little every day. Mary takes a picture of the mushroom each day from Monday to Friday. Which of these pictures were taken on Tuesday?
Okay, so in this problem, what we have to do is we have to figure out which picture was taken on Tuesday. And our clue here is that she takes a picture from Monday to Friday. And also, the smallest is surely Monday because every day grows a little by little. So the smallest is Monday. So when we look at it, B is the smallest, so B is Monday. Next, what we're going to do is we have to figure out Tuesday. And when we look at these, E is a little bigger and not too big. Or it's the next biggest one after that. So E. Then a little bigger after that is C. Because C then will be Wednesday. Because if you look at this, C is the next one that's a little more bigger. But yeah. Now, after that is this, because this one's a little more bigger after that. And after this, finally, the largest one is Friday, so this is Friday. But our main question is which of these pictures were taken on Tuesday? So when we look at that, E was the one taken on Tuesday, so E is our answer.
Which piece completes the pattern?
So, if we need to solve this problem, we have to find which piece completes this puzzle. So, now we have to basically solve this piece. And this piece matches this piece over here, or shape. So, it has to do this. It completes this shape. As well as this star, it should be like this. And it matches this shape. And same here. And now this shape matches this, and we see that it has to be this curve. So if we do this, we could see this is our piece that completes this puzzle. But now let's draw this piece here, the star and the curve. So this is our answer. So if we have to see in the options, let's see which piece matches this answer. So H doesn't match because it's not round, so it's not A. B also does not match this because it's round here, it should be a curve. C doesn't match, also D. And E matches this, it is round, those are points. And that is curved, so E is our answer. Tisker shapes all the squares in the grid where the result is 20. Which shape does he get?
So to find this question, it's asking which ones has the result of 20. So we'll have to find the result of every one and see which one has the result of 20. Let's start off with 16 plus 4. We know that 16 plus 4 equals 20 after solving it, which will equal 20, so we can shade that in. The second one is 19 plus 1, which is also 20, so we can also shade that in. Another one is 28 minus 8, which is also 20, so we can shade this in. Next one is 2 times 10, which is 20, so we can also shade that in. 16 minus 4 is only 12, so we cannot shade this one in, since it's not 12 does not equal 20. And the same with 7 times 3, which is 21, which does not equal 20. So now, the shape should look like there is one in the, it should look like shades all in the top and then one in the bottom, like this. The shape looks similar to A, so A should be the answer. Which of the following figures has the largest part shaded?
So in order to do this, we have to find which has the largest part of green or area of green shaded. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have 2 halves, and 2 halves is 1. So totally 12 plus 1 is totally 13 for A. And as well as for B, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's another half, which makes B 12 and a half. And then C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 2 halves is 1. So 11 plus 1 is 12 and a half, because there's also another half here. And D and E are also 12, and you may do it at your home to check. But in this case, since A is 13, 13 is bigger than all of these 12 and halves, so answer is A. Which one of the figures below can you make using only the shapes here?
So we have a rectangle, 2 circles, an equilateral triangle, a right angle triangle, and a triangle. And we need to find out which ones have all the shapes and no extras. The first one has an extra right angle triangle right here, so A is not correct. B has a square, which we have not seen a square in that area, so B is also wrong. C does not have a circle here, so C is also wrong. D has 2 equilateral triangles, but there's only one, so no. E has all the shapes, like the triangle over there, a right angle triangle over there, all the shapes. So E is correct. So E is the answer. Ellie draws the big square shown in this picture with chalk on the pavement. She starts at the number square marked with 1 and begins jumping. Each time he jumps, she always jumps to a number that is 3 more than the number she is standing on. What is the largest number Ellie can jump to?
Okay, now here it is saying that, let's underline this, marked with 1, it is saying that she always jumps to a number that is 3 more than the number she is standing on. So should we do this together?
Okay.
So if she starts at 1 here, then what is 1 plus 3, Sylesh?
4.
What is 4 plus 3?
7.
What is 7 plus 3?
10.
What is 10 plus 3?
13.
What is 13 plus 3?
16.
What is 16 plus 3?
19.
What is 19 plus 3?
22.
Wait. So let's see. There's no 22 on this board as we can see. And it's asking which is the largest number she could jump to. And since Ellie could only jump to number 19, and 19 is D, D is our answer. George glues these 6 stickers to the faces of a cube. The pictures show the cube in 2 positions. Which sticker is on the face opposite of the duck?
To find out, we need to find out the face that's the opposite of the duck or the other side of the duck. We see 2 images. None of the images are showing the other ones, but there's still one image that is not in any of the images. We have the ladybug over here. We have the mouse over here. We have the duck over here. We have another duck, but we don't have to count that. We have an elephant here and a dog here. None of these are the opposite side, but there's still, the fly has not been shown in any of these images, which means that it must be the opposite side, since that there's still one side that we don't know. So the fly is the answer. Casper has the following 7 pieces. He uses the sum of these pieces to cover this grid completely without overlap. He uses as many different pieces as possible. How many pieces does Casper use? A, 3, B, 4, C, 5, D, 6, E, 7.
Okay, so now what we have to do here, we have to fill this with no overlapping. And also remember, he uses as many different pieces as possible. So we have to use as much or more pieces as we can. That's where you're going to start off with small number of pieces and go to bigger slowly so we could get more pieces here. So let's count. Sylesh, could you help me count?
Okay. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5.
Okay.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7.
Okay, so we have got these pieces all counted. So first let's take this piece and put it here. So let's check it here and I'll cross this off. Next, let's do this piece. Then I will do this, as well as 3. Then I will have to do, then we'll cross it off with 3 pieces. 4 is like this. But now we have 1, 2, 3, 4, 5, 6, 7. And this, we already have counted that this is 7. So we could also take this, put it like this. So we have checked all the pieces that we have used so far. So it's 1 here, 2, 3, 4, and this is 5. So we have used 5 pieces, and so it is C. Cindy colors each region on the pattern red, blue, or yellow. She colors the regions that touch each other with different colors. She colors the outer ring region of the pattern red. How many regions does Cindy color red?
To do this problem, we know that the first part it says is that she colors regions that touch each other with different colors, which means that each color cannot touch the other color. It also says that she colors the outer ring region of the pattern red, which means the outer ring should be red. Now we know those basic things. Now let's go and finally do the problem. Since red is an entire ring and it has 2 other ones that are touching each other, we can see that this one could be yellow and this one could be blue. And then yellow and blue are touching these ones, so the only option we can put this is red. While here, the red and yellow is touching, only red and yellow is touching, we can put the blue here. Here, only red and blue is touching, so we have to put yellow. Totally blue and yellow means red should be in the middle. Totally there are 1 red, which is the outskirts, another red down here, and 3 reds, the third one over here. So totally there are 3 reds, or C. Lois looks at the pyramid from above. What does Lois see?
Okay, in this problem, what we have to do is we have to do it from above. So let's underline. So it says if he looks at the pyramid from above, so what does he see? That's what we have to find out. So in this, what we see is we see 2 orange pieces, 1 red, and 1 black piece. So these are all the pieces that we need to see if it's correct or not. So when we do that, this A has only 1 orange piece. So A is not in our list, or it's wrong. Now B has every piece that we need because it has 2 orange, 1 black, and 1 red. But there's still a problem with B, and that problem is that the orange pieces are more like this next to each other instead of being diagonal. You could tell that by looking at this image. So we could cross B out. C, it looks like it could be our correct answer, as well as D. C and D look alike. And E, though, it's more like A. Since E has only 1 orange piece, we could cross E out of the list. So now our only 2 images that we could select as correct are C and D. So if we need to do this, we have to be very careful. So if you pretend to rotate this pyramid, and then you could imagine these orange sides being this way, then we could tell that the black side is to the right side of it, as well as the red is to its left side. Because then if we do that, we see that this is like this. The black side, remember, is to its right side. So here in D, it's more to the left, and the red is supposed to be to the left. But when you look at it from this way of your paper, you can see the red is to its right side. So D is not correct. So our only answer is C. Dennis ties his dog 1 meter from a corner of a 7 meter by 5 meter hut as shown in the picture. He uses an 11 meter long leash. Dennis places 5 treats as shown. How many of the treats can the dog reach?
So in this question, it says that the dog is 1 meter from a corner of a 7 meter by 5 meter hut, which means that this is 1 meter and this entire thing is a 7 by 5 meter hut, as shown in the picture. He uses 11 meter long leash, or the long leash to the dog. Dennis places 5 treats as shown in the picture down here. How many of the treats can the dog reach? The maximum amount of length that this thing can stretch is to 11. So we can count 11 meters and see how many treats he can reach down here. From 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 4 treats he can reach, and we will need 12 meters if we want to reach that final one. The answer is D, 4. Donkey built a fence using 1 meter long poles. The picture shows a 4 meter long fence. How many poles does Donkey need to build a 10 meter long fence?
Okay, so in this problem, what we need to find is how many poles you would use for 10 meters. So first of all, if you look carefully at this image, you could tell that it has this pattern of F. So if that means, so this, and F would basically be like 1, 2, 3, and 4 poles. There would be 4 poles for each F. So if we think of it as that, then we would need 1 F for 1 meter, another F for the 2nd meter, and a 3rd F for the 3rd meter, and so on with our 4th F for our 4th meter. So if we look at it like that, for 10 meters, we would need 10 F. But we also need to count these 2 poles. So which would basically mean, since we need 4 poles for each F, it means 10 times 4 equals 40. And also remember, we need to add these 2 poles. So 40 plus 2 equals 42. So our answer is 42, which is E. Every time the kangaroo goes up 7 steps, the rabbit goes down 3 steps. On which step do they meet?
So here it's given that the kangaroo will go up 7 steps and the rabbits will go down 3 steps every time. And if the kangaroo goes up 7 steps, it must be a multiple of 7, which the only 2 that are the multiple of 7 is 63, or C, and D, 70. So let's start off with checking 63. 7 times 9 is 63, we know that, so we have to do the same thing with 3. 3 times 9 is 27. But we're going down, so it's, actually we have to do 100 minus 27 to get 73. 63 does not equal 73, so it's not correct. Let's move on to 70. We know that 10 times 70 is 70, so we have to do the same thing with 3. So 3 times 10 is 30. And 100 minus 30 is 70. 70 does equal to 70. So the answer is D. The sum of 3 numbers is 50. Karen subtracts a secret number from each of these 3 numbers, and she gets 24, 13, and 7 as the result. Which of the following of the original 3 numbers? So we know that the sum of all three numbers is 50, and the results of it is 24, 13, and 7. So if we add 24, 13, and 7, we get 44. But it's supposed to be 50, so we have to add 6. But how do we add 6 to this equation? We can simply divide by 3 numbers and then add it to each of them. So 6 divided by 3 numbers equal 2. And then if we add 2, because it's the inverse of subtraction, since that we're subtracting the secret number, we get 26, 15, and 9. We can check this by 2 ways. Adding all the products and you should get 50, and subtracting 2 and you should get the before what we got. And one of them says 9, which is on the answer choices. So the answer is 9.
Emily wants to build a town using 10 copies of this token. When 2 tokens share a side, the corresponding numbers match. 4 tokens have already been placed. Which number goes in the triangle marked with X?
Firstly, we know that the only numbers that can be in a hexagon are 1, 2, 3, 1, 2, 3, 4, and 5. And now, here's the pattern. We know that these two must be adjacent is one pattern, and then every time we add 2, it will become on the other side of adjacent. So, but we have a big problem. When we have 4 plus 2, we'll get 6, which we can't place 6 because we only have 1, 2, 3, 4, 5. This is because, but 1 is basically 6, 2 is basically 7. It's like the pattern 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yeah, and so on. So, and this pattern also keeps on going, but we only need to know 6 and 7 because that 4 plus 2 will equal 6 and 5 plus 2 will equal 7. Now we know that we can continue on to this pattern. 3 will become 3 here, and 3 plus 2 will become 5, plus 2 will become 7, which goes into 2. 2 plus 5 2 plus 2 will equal 4. So X will become 4 at the end. So D is the answer.
So in this problem, we have to remember that he did not break any of the pieces, or he did not overlap any of the pieces. And we have to also remember that short ones that are measuring 1 centimeter and long ones are measuring 3 centimeters. So our square would be like this. But we have to remember that no side is longer than 3 centimeters because it is said that long ones are measuring 3 centimeters. So we have 3 centimeters on every single side. So now, when we do this, we have 4 centimeters. So we would do 4 times 3, which gives us 12. So that our perimeter would be 12 centimeters for this square. So if it has to be 12 centimeters, what we're going to be doing is we will be doing 1 times S plus 3 times L equals 12, which means 1 centimeter for every single short stick. So 1 times the number of short sticks will give us the total number of centimeters for the whole short sticks. And 3 times L means 3 times the number of long sticks, which gives us the total number of centimeters for long sticks. So if we do that, let's try that out with A. So 1 times 5, because 5 is the number of short sticks. So 1 times 5 plus 2 long. And so that would be 3 times L, which is 3 times 2 in this problem, which will give us 5 plus 6, which equals 11. But that is wrong, because our perimeter at the end must be 12. So A is not correct. And B. If we look at B, we have 1 times S, which would be 1 times 3 again, plus 3 long. So 3 times 3, which would be like this. And our overall answer would be 1 times 3 is 3, plus 3 times 3 is 9. 3 plus 9 gives us 12. And 12 and 12 match. So B is our answer. You may also do C, D, and E, but if you do that, 6 short will not be correct or give us 12, or D and E will also not give us 12. So B is our answer. A standard die has 7 as the sum of the dots on opposite faces. The die is put on the first square as shown and then rolls towards the right. What the die gets to the left? What does the die get to the last square? What is the total number of dots on the 3 faces marked with the question marks?
To do this problem, we know that when we rotate 4 times a cube, we'll get the cube the same like it was before. So we only need to rotate it once. When we rotate it once, we'll get to one dot here from here. The 3 dots here will go back down here, and 2 will go same here. And we know that the sum of the opposite faces are 7, so 3 plus x will equal 7, or 4 on the top face. 2 plus 4 plus 1 will equal 7. So the answer is B, 7. 6 people, each order 1 scoop of ice cream. They order 3 scoops of vanilla, 2 scoops of chocolate, and 1 scoop of lemon. They top ice cream with 3 cherries, 2 wafers, and 1 chocolate chip. They use 1 topping on each scoop, and no ice cream desserts are the same. Which of the following combinations are not possible?
Okay, so in this problem, the thing is that, so for example, first we could do this. So we have to underline this. They use 1 topping on each scoop and no ice cream desserts are the same. Which means that, for example, you see the vanilla here. So if this vanilla has a topping of cherry, then these 2 vanilla ice creams should not have a topping of cherry. So on with that with the chocolate and lemon. So if this vanilla has a topping of cherry, then this one should not have cherry. The leftover 2 toppings could be wafer or chocolate, so we could use wafer. And the next vanilla should only use the chocolate chip. So we can cross out 1 cherry, 1 wafer, 1 chocolate chip. Next is this. So for the 2 chocolates, we have 2 cherries and 1 wafer. So if we use cherry for chopping for this, then we would have to use wafer for this chocolate chip because that's the only one we could use. And for lemon, our thing is that we could only use cherry because that's the only one that's remaining. So with that, let's look. So whichever one that is not here is our answer. So A, chocolate with a cherry. There is a chocolate with a cherry over here. So A is wrong. Next, B, vanilla with a cherry. Vanilla with a cherry is our first one here. So it's wrong. C, lemon with a wafer. Lemon with a wafer is not here because there's only a lemon with a cherry. So C is our answer. The queen tries to find out the 3 names of Rumpelstiltskin's wife. She asks her, are you called Adele Lily Cleo, Adele Lara Cora, or Abi Lara Cleo? Each time exactly 1 name and its position are right. What is the name of Rumpelstiltskin's wife? A, Abi Lily Cora. B, Abi Lara Cora. C, Adele Lara Cleo. D, Adele Lily Cora. E, Abi Lara Cleo.
To do this problem, if 2 of them are right, that means two names and 2 of its positions are right, which we don't want. So it cannot be Adele, or it cannot be Adele, which means it has to be Abby. The same thing goes with Laura. Laura, there's 2 of them, so we can't do that, and there will be Lily. Cleo with the same thing, we'll get Cora. So the answer is Abby, Lily, Cora. Abby, Lily, Cora is on problem A, so A is our answer for Abby, Lily, Cora. The teacher writes the numbers from 1 to 8 on the board. The teacher then covers the numbers with triangles, squares, and a circle. If you add the 4 numbers covered by the triangles, the sum is 10. If you add the 3 numbers covered by the squares, you get 20. Which number is covered by the circle? A, 3, B, 4, C, 5, D, 6, E, 7.
Okay, so in this problem, the thing is that, well, let's underline first. It said that the 4 numbers covered by the triangles, the sum is 10. So, well, and also it's given that the numbers are 1, 2, 3, 4, 5, 6, 7, and 8. Because it says that the teacher writes the numbers 1 to 8. So that's the numbers, 1 to 8. We have every single number wrote down. So we have to take 4 numbers and the sum of them should be 10. So let's try 1 plus 2 plus 3 plus 4. Would you add 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. Which means that these 1, 2, 3, and 4 are the numbers behind the triangles. So we can cross them out. And now we have 5, 6, 7, 8. So the sum between the numbers that are covered by the squares is 20. So if we take 7 plus 8, what do we get? 15. But that's wrong because we have to get 20. So 15 plus 5 only gets 20. So which means that the 7, 8, and 5 are the squares, because if you add them, you get 20. So we can X them out. So our only thing that is left is 6. So 6 is the only one that is inside the circle. So 6 is our answer. So we could circle 6 for D. Jane has some drawings of parrots. She wants to color only the head, tail, and wings of each parrot red, blue, green, so that all 3 colors are used on each picture. She colors one parrot's head red, its wings green, and its tail blue. Jane has some drawings of parrots. She wants to color only the head, tail, and wings of each parrot red, blue, green, so that all 3 colors are used on each picture. She colors one parrot's head red, its wings green, and its tail blue. How many more parrots can she color so that all the parrots are colored differently?
To do this question, we know that there are three colors, red, blue, and green. So to find out how many options there are with all 3 colors, we need to do 3 factorial, which will get us 6. But there's no 6. That's because they're asking how many more, and they're already mentioned one of them here. So it's subtracted 1. 3 factorial will equal 6 minus 1, which will equal 5. So the answer is D5.
Several teams came to the summer kangaroo camp. Each team has 5 or 6 members. There are 43 people in total. How many teams are at this camp?
To do this problem, we know that there's 5 members in some teams and 6 members in some teams. And this equation marks that 5x as 5 members in some amount of teams and 6 members in some amount of teams, which will equal to 43 people in total of all total members. So that's why I put this 43 in the back. Now we can insert different values of x and know the y value. And you can't have 0.5 teams, right? So we need a whole number to do this problem. At first, if we put x equal 8, we're starting with 8 because it's the easier number. And plus, if we do x equal 9, x equal 10, it's going to be greater than 43, so it's 100% going to be wrong. So if we do this, the first one, x equal 8, will get us 6y equal 3, which does not make sense. X equals 7, you get 6y equal 37. X equals 6, then you'll get 6y equal 13. If you do x equal 5, you get a 6y equal 18, which is divisible to y equal 3. That's just the amount of 6 member groups. We need to add it to the amount of 5 member groups. So 5 plus 3 equal 8. So totally there are 8 teams, or D, which is 8. Which key would be impossible to cut into 3 different figures of 5 shaded squares?
Okay, so in this problem, what we have to do is that we have to make sure that there are 5 pieces in each, and we have to make sure there are 3 pieces. And one important thing, all pieces have to have the same number of squares and have to be the same shape. So let's look at A. So if we look at A, we have 1, 2, 3, 4, and 5. So we could cut this one piece, and then this way it'd be 1, 2, 3, 4, 5. So this is another piece. But here, with it can be 5 pieces. That's not a big problem. But the thing here is that it's not the same shape as this, because these two are the same shape, but this is not the same shape. This is a different shape. So A is wrong. When we look at B, it's 1, 2, 3, 4, 5. So let's write it like this. And after this, we could cut that like that. Now we have another 1, 2, 3, 4, 5. So it would be this piece. 1, 2, 3, 4, 5. And this one would also be another 1, 2, 3, 4, 5. But the thing here is that when we look at the pieces, we have every piece, if you look at it carefully, we could tell that it is all the same. So B is our answer. But you could see, we could also check in C though, just in case to make sure. So if we look and see, we have 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So this shape is like that. And 1, 2, 3, 4, and 5. So that. But when we look at this problem, it says it's like this, and this shape is also the same, but this shape here is not the same. So C is wrong. And if we look at D, it's 1, 2, 3, 4, 5, which is good. If we look at this, it's 1, 2, 3, 4, 5. So we could do this. But even if we look at this one, we have this 1, 2, 3, 4, 5. But here, you see this, all of these pieces are different. Because this is a different shape, this is a different shape, and this is a different shape. So D is wrong. And when we look at E, we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 again. And lastly, another 1, 2, 3, 4, 5. So in this problem, though, they're all also different, just like one of these. So A is also wrong. So our only answer that is correct is B. And replaces letters in the calculation can plus ga minus ru with sum of the numbers from 1 to 9 and then calculates the result. The same letters are replaced by the same numbers and different letters by different numbers. What is the largest possible result she can get? A 925, B 933, C 939, D 942, E 948.
To do this problem, we know that we need the largest possible result, and we need to place numbers 1 to 9. And we know that the same letters replaced by the same number, and different letters are replaced by different numbers, which means that there's no repeating. So to get the biggest number, we can put 9 in the hundredths place of can, because there will be, remember, we need to get the largest amount. Then 8 for A. We're not going to put n by 7 because we can already place n7 here in the tens place, and it will be greater than 7 in the ones place. Then we can place 6 here. In this A should equal this A, which is 8. So 8 should go here also. If we are subtracting a number and want to get the largest, we need to have the smallest value subtracted by. So the smallest value we can get is R equal 1, R equal 1, and O equal 2, or 122. If you do 986 plus 78, you get that will give us 1064 minus 122, which will get us 942. So the answer is D, 942.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrico.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!